Welcome to today's deep dive. So, if you've ever settled in to watch a massive live event like a global sports final, you just sort of expect the video on your screen to be absolutely flawless.
Right, you don't have to think about it.
Exactly. But you rarely think about the physical cords actually carrying that massive signal out of the stadium. So today, we're looking at a product page from HDTVSupply for this highly specialized piece of broadcast hardware. It's the AJA FiDO-TR-12G single-mode LC fiber transceiver.
Yeah, that is quite a mouthful. But our mission today is really to decode what that complex little device actually does. We want to explore how high-end AV technology solves the massive logistical problem of transmitting pristine video over extreme distances.
Okay, let's unpack this, because the main party trick of this device is just wild. It takes massive 12G-SDI video signals, which is really just the industry term for extremely high-resolution, uncompressed video.
Right, the stuff that includes dense HDR metadata.
Yeah, exactly. The digital instructions for perfect color and brightness. So it takes all of that and converts it to run over single-mode fiber optic cables. It's like taking this raging river of data and funneling it into a precise, high-speed laser beam.
I like that analogy. And what's fascinating here is the sheer scale that laser beam unlocks. Like, when wiring sprawling arenas with traditional copper cables, high bandwidth video degrades very quickly.
Oh, so the signal literally just falls apart.
Exactly. It falls apart over a really short distance.
Yeah.
But this AJA transceiver allows for cable runs up to 10 kilometers.
Wait, 10 kilometers? I mean, if I shine a laser pointer down the street, the beam spreads out and fades into nothing pretty fast. How does this box keep a light signal perfectly intact for over 32,000 feet?
Well, it comes down to the single-mode part of the cable. Unlike multi-mode fiber, which bounces light off the inner walls of a wider cable for shorter runs, single-mode uses a microscopic glass core to shoot a single direct path of light.
Oh, wow, so it doesn't bounce around at all.
Right, the light stays completely contained, meaning that heavy data load can travel miles to a broadcast truck without losing a single pixel of quality.
But if we're talking about a laser powerful enough to shoot pristine data 6 miles down a glass tube, you'd picture a massive, heavy machine. Yet, looking at the specs, this is a really compact, low-profile box.
Yeah, it was surprisingly small.
Right, and it only uses 4 watts of power running on 5 to 20 volts DC. It's designed to be tucked away directly on a camera rig or shoved behind incredibly crowded equipment racks.
Getting that much capability into a small form factor is necessary, though, because it has to sit right at the source of the video. But the real magic is the technical precision happening inside that little box.
You're talking about the reclocking feature, right?
Exactly. It automatically detects and retimes video rates from 270 megabits per second all the way up to a staggering 11.8880 gigabits per second.
I mean, I understand it's handling a ton of data, but what does retiming actually mean in practice? Like, why does a video signal need a clock?
So as digital signals travel, the ones and zeros can start to drift out of perfect timing. It's an issue called jitter.
Okay, jitter, got it.
Yeah, and if that messy, jittery signal hits the broadcast truck, the video drops. So reclocking reads that slightly degraded incoming signal, extracts the timing data, and regenerates a brand new, perfectly timed signal to send onward.
So it ensures the video doesn't just reach its destination 10 kilometers away, but actually arrives perfectly synced.
Exactly. And given how sensitive this syncing process is, I imagine a single incompatible switch in the stadium could ruin the entire broadcast.
Oh, for sure. Is that why buying this isn't just a matter of, adding it to a digital cart?
Yeah, building complex AV infrastructure requires a cohesive ecosystem.
Yeah.
You aren't just buying a transceiver, you're integrating it into a massive chain of equipment.
Which really explains the vendor here, HDTVSupply. They have a 25-year history in this space and a massive catalog of their own Wolfpack matrix switchers and video walls.
They really know their stuff.
They do. And what really stood out in the source material, though, were the customer reviews. People specifically praised the support staff by name, like Rachel and Mike.
Having human expertise to guide the purchase is critical to avoiding incredibly costly compatibility mistakes. You need a knowledgeable human to ensure your highly specific fiber transceiver actually communicates properly with the rest of your massive switching system.
So what does this all mean for you listening? Even if you aren't building a broadcast truck, understanding these invisible devices reveals the hidden infrastructure that brings flawless live video to your
It
screens.
really does. It takes the incomprehensible density of modern video data and literally tames it into light.
It's wild to think about, and it leaves you with a lingering question to ponder.
Oh, what's that?
Well, if a box this small, tucked behind a camera, can currently push flawless, uncompressed 12G video over 10 kilometers using light, what unimaginable volumes of data will fiber optics allow us to transmit in the next decade?